Hello, welcome to Physics Meal. Physics Meal is a branch of our Mathematics and Science Meal program designed for students. We designed this program to help students in the study of physics, chemistry, biology, mathematics, and even further mathematics. So as you follow us, these subjects will become very easy for you. Alright, today we are going to look at breakfast question 1. Breakfast question 1. I know maybe you have eaten today, but your meal is not complete until you enjoy physics meal. Now this breakfast question is from the concept of equilibrium. The concept of equilibrium. So we're going to look at this question and provide solution to it. Alright, let's look at the question together. They say find T1 and T2 if M of weight 20 Newton is in equilibrium. So this is a tension on a string. So they kept this particular body of weight 20 Newton in equilibrium. So we need to find the value of this tension and also this tension. Now you remember that if we are solving problem on equilibrium, when a body is in equilibrium, there are conditions that we must take into account anytime we want to solve problem in equilibrium. If a body is in equilibrium, then the sum of the vertical upward forces will be equal to the sum of the vertical downward forces. In other words, the algebraic sum or the vectorial sum of all the forces acting at a point will be equal to what? 0, or acting on the body will be equal to 0. The same thing, if you now, this particular condition, we can break it down to sum of vertical upward forces will be equal to sum of vertical downward forces, and also sum of the horizontal forces to the right will be equal to sum of all the horizontal forces to the left. Then that's the first condition. Remember, there are two conditions that will always keep a body in equilibrium. One is the force condition, and the other one is the moment of force condition. The force condition and the moment of force condition. So let's begin. Now we have three forces. We have a tension, we have the tension, another tension, then we have the weight of this. Now if we look at these forces, we need to break it down to the horizontal forces and the what? And the vertical forces. So let's look at the horizontal forces. Let's look at the horizontal forces. Now we know that this force is horizontal, that's this tension. It's only horizontal. This one is only vertical. It doesn't have, it has no horizontal component. This one has no vertical component. But this one that is inclined at a certain angle, we have both horizontal and the vertical component. So let's list the horizontal forces. The first horizontal force that we have here, the horizontal force, the horizontal forces. The first one is T2. T2 is a horizontal force. It has no vertical component. Then this one, there is no horizontal force here, it's just a vertical force. Then this one, T1, will contain both horizontal and the word vertical. So what is the horizontal component of this particular force, T1? The horizontal component of T1, which I can call Tx1 for horizontal. You know, horizontal is the x. So Ts1. If we resolve this, when we did resolution of forces, we saw that if we have this, if this is a force, this is the vertical component we call Fy, this one the horizontal. We remember that the angle we use for resolution is the angle which the force makes with the word, with the horizontal. So this is this. So the horizontal component using trigonometry, Fx over F will give me cosine theta. That's adjacent over hypotenuse. So it means that Fx will give me F cos theta. So if we apply that here, the horizontal component of this force is going to be T1 cos 30. T1 cos 30. That's what we are going to have, the horizontal component of this force. Then There is no other horizontal component here because only this force we have both horizontal and vertical. This is the horizontal force. This has no horizontal force, it's a vertical force. Remember that the horizontal component of a vertical force is 0 because a vertical force has no horizontal component. So the two horizontal forces we have is T2, and then the horizontal component of this inclined force T1, inclined tension T1, which we have just found. Alright, now we need to find the vertical forces. So what are the vertical forces here? The vertical forces. What are the vertical forces? Okay, we take away this. Let me write it somewhere here. If we have a force and the angle is theta, and then we have Fy, and this is Fx. Now what will be the vertical component of this force? That's what we are talking about. The vertical component Fy over F will give us sine theta, opposite over hypotenuse. So Fy becomes F sine theta. So the vertical forces Ty1 will give me T1 sine 30. That's what we are going to have. T1 sine 30. Then the other vertical force will be W equals 20 Newton. Okay. Now, following the conditions for equilibrium, you will notice that this particular vertical force will be acting upwards. The weight is acting downwards. So it means that the upward force will be equal to the downward force. Very simple. So this upward force will be equal to this downward force. So let's look at that so that we can find our Ty. We have found our horizontal forces and we have found our vertical forces. Also here, this Ts1, the horizontal component of this force will be acting towards the left. And we say that the sum of the horizontal forces to the left will be equal to the sum of the horizontal forces to the right. Now this one is pointing to the right. The horizontal component of this is to the left. So let's begin with this because here we have two unknowns. So let's solve this first. What it means is that Ty1 will be equal to W. These two will be equal because the upward vertical force will be equal to the downward vertical force. So if that is the case, Ty1 is equal to W. What is Ty1? It is T1 sine what? 30. It's equal to what is W? 20. Now sine 30 we know is 0.5. So T1 times 0.5 is equal to 20. So it means that T1 automatically becomes 20 over 0.5 and T1 becomes 40 Newton. Now having found T1 now, we can use it to find T2, excuse me. So if we look at this now, the horizontal forces to the left will be equal to the horizontal forces to the right once the body is in equilibrium. So Tx1 will be equal to what? T2, because they are the only horizontal forces we have. So what is Tx1? Tx1 is T1 cos what? 30. That will be equal to cos 30. That will be equal to T2. Now, what is T1? We have found it to be 40 times. What is cos 30? With 3 over 2. When we do that in using solid form, equals T2. Okay? Now, 2 can divide this. We have 20 with 3 equals T2. So, T2 becomes 20 with 3 Newton. That's our T2. Alright, that's all about that. I believe you enjoyed this breakfast. Now you can go about your business. Remember, any day you did not feed on mathematics meal, physics meal, or chemistry meal, you are still hungry. Don't mind me. We shall come back in our subsequent videos to look at other meals. We still have physics meal, physics breakfast, we still have our chemistry breakfast, We still have mathematics breakfast. We still have different forms of breakfast and lunch and even dinner that can help you as far as the study of sciences and mathematics is concerned. Thank you, and God bless you.